Thank you, George. Good morning, everyone. Pleasure to be here in Lisbon again. Let me just take a minute here. George mentioned that the whole conference started because of my wife, Carmen. What he did not tell you that she is not here. She did not make it. Actually, she's been to Portugal before, Lisbon, and we just love the culture. We love the people, the food, the company, of course, Dr. Souza and his family. It wasn't really a selfish part in her thing. She wanted to create a meeting so she can bring her parents over. They traveled the world except Portugal. And, but however, her 87-year-old father, he's a physician. And he had a conflict at his medical office, so he decided he will pay attention to his patients instead of coming at this time, and they pushed back later on for the summer. So anyhow, I just wanted to mention this, so not to blame my wife, but I am looking forward for a Green Pavements Part 2 at some point next year for that. My presentation is entitled Environmental Benefits of Using Asphalt, Rubber, and Pavements. I really think it might create a good link of the topics that the previous speakers, experts, the keynote speakers, discussed about some of the technology there, and maybe set the stage for the speakers that will come after me. So it's really a great transition. It wasn't really planned this way, but as I was listening and I was looking at the program, I thought that would be really a good connection there. So we have this global environmental issues. I read an article back in January looking at climate change and severe environmental problems. Again, the kids this morning were a nice surprise for all of us. But this is actually an article on the power of an idea, the international impacts of the grand challenges for engineering, written by three distinguished people from the Royal Academy of Engineering, the US National Academy of Engineering, and the Chinese Academy of Engineering. And they address problems that we're trying to handle today through the Green Pavements seminars and conference. One of the things that kind of resonated with me is, you know, if we continue on consuming the Earth resources at the pace currently we are doing, humanity cannot be sustained in such a fashion. You can agree or disagree with it, but I think there's a lot of truth to that based on a lot of facts that we know. And then you heard a lot about sustainability today and from the previous speakers, and sustainable growth is really essential. And I think this is really the tone of this conference that we're trying to accomplish here. Urban renovation and reinvention pose complex challenges, and it's very true. So even though that we think this is the path we want to follow, I think we are all administrators and engineers in this room are faced with some of these complex challenges. And we will hear more about those throughout the couple days. Just to kind of confirm this climate change, when I talk about climate change on pavements and roadways, I like to show this figure. To me, it's undisputed figure in terms of the intensity and the frequency of the extreme weather events that we see or we have seen in the past decades regarding extreme temperatures, wildfires, droughts, storms, and floods. The data doesn't lie. What you see here is actually an increase of these occurrence of the events. And the cost that, you know, beside, of course, the cost of life, the damages that we have is in billions of dollars. So trying to mitigate or trying to address some of these issues, it's really a great thing for what we do. In terms of challenges for us in engineering, we have a lot of urban chaos or disorders, traffic congestions, severely stressed infrastructure, worsening quality of life. These are here to continue. We need to find better solutions as engineers. They act like a motivation for all of us to seek good solutions to address them. And can I give us a charge for the engineering profession to be responsible in creating that type of future we are looking for. So this is grand challenges in engineering, and pavement engineering is actually a very essential part of what we are talking about, and it has to be addressed through this effort as well. So we talked about sustainability, sustainable. Dr. Poti actually presented a very nice view of what's going on. So I'm going to give you my twist. And again, the intention here is to kind of bring in all the different elements and the focus on these asphalt rubber technologies or asphalt rubber pavements. So when we talk about sustainability, we must show this figure, right? This is the pillars of sustainability. You have to address issues related to the social impacts, the economic impacts, and the environmental impacts. And again, we talk about environmental issues today. If we do that, then we are actually on the sustainability path. Pavements should be also right there in the middle, okay? Pavements should be addressing those three issues. As a pavement engineer for many years, early on, I didn't really address environmental issues. We didn't care much about social impacts. We just look into how cost effectively we can build a project or a pavement to make it work better and last longer. But now we have to consider all the other elements. So here's a nice definition for what a sustainable pavements should look like. A socially friendly, a durable and resilient, and have minimum impacts on the environment. It's the description that I like to use. And therefore, we can talk about sustainability on a sustainable pavement in this theme or in this context. So I'm going to put some links here. This figure is not inclusive of all the elements that we can talk about, obviously, but I just want to bring out some of these elements that we can actually include for sustainable pavements. So on the social part, we heard about performance and durability. And that's a great thing. We also definitely were concerned in safety. In fact, safety should be the #1 issue for our designs. And a lot of places, I'm sure here in Portugal, in Europe, in the US, ride quality, the smoothness of a roadway is also of utmost importance to the users that we have. There is an urban heat island in a place like where I come from the southwest, Phoenix, Arizona. The overheating of the infrastructure and re-emitting that heat back to the atmosphere becomes an issue. So it's actually, it kind of embedded there between the social, because you have an increased energy consumption, environmental aspect as well too. But we can add these 4 items, impacts on air quality for the type of roadways that we use. The noise pollution, there was also mentioned, noise pollution nowadays considered as a pollutant, as part of the environment. Recyclability of the materials. In pavements, I think we are fortunate. Just about everything we use is recyclable in some form, so that's not a huge issue. And then energy savings. So we're trying to address those issues in addition to this economic benefits or the life cycle cost benefit that we must have there. Like I said, this is just basically an overview of what a sustainable pavement in our center's view, what it should look like. I can replace sustainability with green. I had a discussion with some of the colleagues here. Can you actually call sustainable pavement as a green pavement? Of course, yes, you can. Green pavements, you're more focusing on environmental issues. However, you cannot address environmental issues without really addressing also the social and the cost effectiveness. So they're kind of all tied in together. So in a way, what I'm presenting here is a thought that a sustainable pavement is also a green pavement and vice versa, okay? Whether you really, we agree, all of us, with that or not. And then the most important part, we talk about asphalt rubber. So in asphalt rubber pavements, does it really fit all of these different themes that we have? Okay, so asphalt rubber pavements, as I will show you here, it is actually a sustainable pavement, it's a green pavement for the many benefits that we have seen over the years. So in the next few slides, I really have a story to tell, okay? So this is really nothing new that we have done recently. It's just a collection of studies that we have done over the years with experts, like the Arizona Department of Transportation, George Way, with the help of Dr. Souza, experts from Brazil, Dr. Pinto, Sweden, Thorsten is here in the audience as well too. So these are a collection of studies that we have done to document certain elements of these social, economic, as well as the environmental benefits of the asphalt rubber pavements. In Arizona, we have done 10 years of laboratory studies in connection with field evaluations of mixtures to study their performance, their behavior. All these studies have showed that they are excellent performing materials. You don't really need our laboratory studies to show that. The field performance itself kind of showed us as well too. These are some of the different projects that we work with, and also the entities, including Alberta, Canada, Sweden, and Brazil. Also, away from the Arizona State University, the Federal Highway Administration, and they have done some test sections. You will see that later on in some of the speakers' talks. So again, I don't want to take the thunder away from their presentation. I'm just trying to look at the asphalt rubber performance and durability element of that social functionality block is really satisfied by that asphalt rubber pavement material. Where on the left-hand side here, I'll probably see it right this way, this is your asphalt rubber section comparing to everything else that they have experimented with. And I think, like I said, the other speakers will talk a little bit more about that. In every slide I have in here, and these slides will be made available for you, even though this is a summary of the projects, if you need more information, these are some published reports, published papers that actually have more documentation on every single topic I'm talking about here today. Okay? So these will be available for you, and therefore I'm not going to repeat this over and over. Asphalt rubber performance in terms of cracking, in terms of rut depth, have shown over the years they are superior to conventional mixtures, so there is no brainer about that. Okay, that's really satisfy the performance and durability criteria I'm looking for. Asphalt rubber friction courses overlaid on top of Portland cement concrete it wasn't really by chance, or maybe it was, they have unintended benefits. What you see over here is actually some test sections that we have monitored with a friction course material versus no friction course on Portland cement concrete. What we were looking at here is to see what is really the impact in terms of the temperature gradients. So we instrumented those pavements with thermocouples. We looked at the difference between with and without the asphalt rubber friction course. And what you have seen here is actually the one with the asphalt rubber friction course have a lower temperature gradients, lower delta T. If you're designing concrete pavements, lower delta T means it will have less of curling stresses that develop on the slabs. So it's actually a better, longer life or good news for Portland cement concrete pavements. And in fact, we quantified that by showing somewhere between, depending on the time of the year, between 8 to 25% reduction in the curling stresses. So that's really an added benefit of these friction courses. The friction course by itself, by design, it's a great way to improve the friction characteristics of the surface. Asphalt rubber friction courses have shown that improvement in friction values and provide more consistency in the results, for projects. And again, this is one of the projects that we have done. Some of you might say, well, we don't really have to have an asphalt rubber friction course. We can have a conventional friction course. Yes, you can provide the same skid resistance benefit, right? However, ARFC will last longer. What you see here are some photos of some sections on the I-10. They're probably about 10 or 11 years old with hardly any cracking in these asphalt rubber friction courses. Just adjacent to those, conventional friction courses, they crack. You have fatigue cracking, you have transverse cracking, they show graveling, sign of graveling. So again, that deterioration really will degrade the quality of that surface, and therefore it doesn't really fit in that criteria. There are great surfaces to reduce the amount of splash. Again, this is really from the Phoenix area, even though we are in a dry climate, we do have storms in the summer, and our highways could get flooded. So actually what you see here at the bottom right-hand side, that's a great way to mitigate that excessive amount of water that you see from conventional roadways. On the bottom left, you see a concrete surface versus a concrete surface with asphalt rubber friction course from I-35 in San Antonio, Texas. What about ride quality? Well, ride quality, having a thin layer from a construction aspect, the contractors really have a great handle in terms of getting a better ride or a better smoothness. Documented through one project here where we overlaid the Portland cement concrete pavement. You can see the amount of IRI has been reduced to a much lower numbers. And again, the graph on the right-hand side, you will see several projects over the years. George Way, he'll talk about some of those later on, but you can see that in general, smoothness is much better achieved with these types of material. As for rubber and urban heat island, this is an aster image of the Phoenix area. Everything you see in yellow, was taken about 11 o'clock at nighttime. It's about 30 degrees C surface temperature in October. Okay, so this is actually very warm. So, and what you see here is actually a very well-defined high surfaces of the road network in terms of the temperature rise there. So all the highways are actually highlighted with yellow or have higher surface temperature comparing to the other location in green and blue. 40% of our urban area in Phoenix is covered by some type of a paved surface, whether it's a parking lot, a roadway, a local roadway. And if I take the top 20% of these high temperature roadways, they are really shown in this processed image on the right-hand side. One of these images, just to give you an example, when we looked at, this is Interstate 17 in the Phoenix area, just north of downtown. Here's the airport down here, massive infrastructure. What you see is actually this is a cooler surface comparing to the top part. And in fact, the top part is a Portland cement concrete at that time, where this section right here is actually overlaid with asphalt rubber friction cores. So we have learned that because of the porosity of the thin layer structure, it actually can provide a mitigation for the urban heat island at nighttime. That's what the pavement looked like. Again, a 19 millimeter of an asphalt rubber friction cores on top of the concrete layer. There are many driving factors for urban heat island effect. I'm not going to go through all of these because of the time, but the canyon geometry, whether you have a depressed section or it's at grade, can make a difference in terms of the cooling and the heating of the material. But there is also other factors as well too. There is also other fundamental properties of the mix itself, the reflectivity, the albedo, the emissivity, the thermal conductivity of the material, the specific heat, the density. So all of these are actually also will control the type of heat exchange or heat transfer that takes place into that material, into that layer. Usually thinner layers are more desirable. Porous layers are more desirable in this case. Lower thermal conductivity is more desirable, and specific heat, obviously. So these properties are actually really will work in favor of the friction courses for asphalt concrete. We have done many laboratory evaluations just to show you an idea about how we can actually capture some of these thermal conductivity for various materials. We're using a cylindrical specimen type. We have done test sections where we build different thicknesses. We monitor those sections with a thermocouples embedded in pavements. Again, this was in conjunction with George Way over the years at ADOT. We have concrete sections of various thicknesses and various materials as well too. And we get temperature profiles like what you see here. I just want to point out very quickly, if you look at asphalt rubber, this was actually placed on a highway where it's an HOV lane but has no traffic. It gives you the highest temperature during a day. It's very normal. That's time for me to stop or what? No? Okay. If you look at the asphalt rubber in a driving lane, the same material, you can look at the blue lines. Actually, the peak temperatures are lower. In fact, look at the nighttime temperature. It's probably give you the coolest because of that porosity. So again, there is plenty of knowledge and information that have been captured from such studies and showing that porous materials like the asphalt rubber here is actually great in mitigating these temperatures during daytime as well as at nighttime. Best temperature is good. We've used these type of input in models so we can actually study different pavement designs. So it's really very helpful to do that. Moving on to the next item, I found another interesting article back in January, actually on BBC, and talking about highway noise and health. One of the things that brought my attention, if you look at the title of this article, dementia rates are higher near busy roads, okay? And if you go through the article, you can Google it, they talk about pollutants, have more pollutants around the highways, possibly will add to this higher dementia rates, but also highway noise itself, generated all that traffic and congestion, also will contribute to these higher percentages. So the researchers who followed nearly 2 million people in Canada over 11 years say air pollution or noisy traffic could be contributing to the brain's decline, okay? Even though they have made that statement, if still cautionary, there is no hard conclusion, but it makes you wonder, it makes you think, why these higher rates are actually captured around those. And I think to a certain extent, these are very logical or rational. So highway noise is great. Actually, we use the asphalt rubber friction courses in the Phoenix area because they give you lower noise. We have seen somewhere between 12 to 13 decibel reductions. You will see that a little bit later on. We have a little tunnel experiment that we have done, noise studies outside the tunnel, inside the tunnel, in driving car. These numbers show anywhere between, like what the previous speakers talked about, anywhere between 4 to 11 decibels reduction, which is great. Anytime you can have 2 or 3 decibels, this is really fantastic in terms of noise reduction. Going back to the same BBC articles, here's the breakdown. 70% higher within 50 meter of the urban highways, 4% higher between 50 to 102% higher between. This is the results of what they talked about. But they also talk about this pollution particles can possibly add to that complexity of this health issues that some of these people had been witnessing. And again, this is Dr. Chen from the Public Health Ontario reported that increasing the population growth, urbanization have placed many people close to heavy traffic, and with widespread exposure to traffic and growing rates of dementia, even a modest effect from near road exposure could pose a larger public health burden on that, okay? And the reason I bring this up, because when we studied the tire wear emissions that you get from road surfaces, tire wear will add to the pollution, air pollution that you have in an urban environment. So the study we did back in 2004, 2005, our intention was to see if your asphalt rubber surface actually can give you higher or lower tire wear emission, okay? So it really have to be engineered in a way that you can capture the similar environmental conditions, traffic conditions, obviously, for that purpose. Without going through a lot of details, what you see over here is actually the exit of the tunnel. The tunnel in the Phoenix area was a great location because we can actually get some aerosol samples from there. We use the chimneys from these tunnels to kind of put our equipment in there to collect these aerosol samples. We analyze those samples to see the amount of pollutants or what type of pollutants that we have. We had to identify our tire markers as part of that. So we gouge all the tires we can at the tire yard. And we identify 2 compounds related to tire wear. And then you can see the experiment before and after the asphalt rubber friction course. Almost about a year later, you can see that the amount of particles have been reduced. And compound number 3 is almost by half. And number 4 is also a significant reduction with a plus-minus confidence values in there for this. So the conclusion here was really that these asphalt rubber surfaces actually will have a less tire wear emissions comparing to, in this case, what we have done for Portland cement concrete. And there have been some other studies in California looking into asphaltic materials and so forth. Again, the publications on this is there for your record. Recyclability within this environmental criteria. I think George might touch upon this later on, but we have been successful in recycling the asphalt rubber in the Arizona. That's not a problem, which is great news. Again, you're saving a lot of on energy, resources, and so forth. We heard a lot about CO2 emissions this morning, even from the kids. CO2 emissions, we have done a study, and I think I just want to really maybe breeze through all of these background, just because this information is available online as well too. But we're looking at this manufacturing process of the raw materials, whether it's a Portland cement concrete, an asphalt material, pavements, or asphalt pavement with a rubber component. How do you calculate the amount of CO2 emissions during this production phase, during the transportation phase, and the placement, and so forth? So we went through a study where we actually obtained from a Swiss database, obtained the global warming gas potentials that can be converted to the total kilogram of CO2 equivalent. And this applies really for Portland cement production, the gravel production, the sand, the asphalt cement, electricity usage at the plants, and so forth, okay? So we kind of documented these numbers. We also developed a simple models accounting for all of these different elements. And if what you needed here is also the thickness and the width of the roadways, in addition to how long it's going to last over the period of the design. So that's your Y parameter. And obviously, this has to be a user input to account for such modeling. Again, without going through a lot of the definitions here, we have calculated basically the total kilogram CO2 equivalent for production for Portland cement concrete. We have done it for the HMA production. We have done it for the asphalt rubber production. And you can see here the crumb rubber in terms of shedding and how much of that is adding to the total. So we quantified the mixing by identifying the amount of fuel, the type of fuel being utilized, and crumb rubber, what's the shredding mechanism, how much energy you use, and what's the output, and so forth. So you can see the numbers there for yourself. And then we come up with a total mixing values for each pavement type that can be used in our analysis, in our pavement design. So that, again, really in terms of the energy evaluations as part of this environmental criteria. And then when we do this, we summarize all this information that was used in the previous model that I showed you. And then here's an example how this information was used. So I'm assuming here I have a design of an asphalt rubber 62 millimeter on a base of 150 millimeter. It's going to last me for 10 years, okay, just a number here. The equivalent of 100 millimeter is what we have been using in Arizona, what California also uses. Use your half thickness design criteria, in this case about 60%. You can reduce the thickness by 60% to have the equivalent because of the material property change. And then I also compared it to a UTW ultra thin white topping of 50 millimeter of concrete on top of a HMA base and the same base here. And I gave this one more 15 years duration. You can see here the quantification of the transportation, mixing, and production. And there, if you add the total, again, it's no-brainer. It's a rational way of looking at expecting these results. If you use lower thickness or less material, you're going to end up with a less CO2 emission. So in almost every asphalt rubber case design, we have seen that reduction in the CO2 emissions because of these benefits. Cost effectiveness, we have done a couple of studies, but again, I think the better documentation you will see is actually from the asphalt rubber standard practice guide, where documentation from the Arizona Department of Transportation over the years show that really you have much lower maintenance costs for asphalt rubber pavements, and therefore they are really more cost effective in the long run. So again, the upfront cost might be a little bit more, but but if you look at the long run, they are really ahead in terms of the cost effectiveness. So in conclusion, the case I'm trying to make here is that within this sustainability, sustainable pavements, the green pavement criteria I described early on, that I'm saying that the asphalt rubber pavement really fit that definition, fits this theme. You're going to hear more from other speakers about their studies. It's a socially friendly, durable, resilient, and have lower impacts on the environment, which is something we want to have. It can go back to these earlier concerns that I presented earlier, who have less consuming of the earth resources, obviously, and provide better opportunity for this sustainable growth. So with that, I think I put us a little bit ahead of schedule, as we discussed here, and thank you for your attention. I don't know if you're taking questions now or maybe later. Okay, we are. Thank you.